Welcome to section 4.8, L'Hôpital's rule. It's spelled La Hospital. Some people leave the S out, but you say L'Hôpital. And so L'Hôpital's rule is a way to evaluate limits that are infinity over infinity or 0 over 0. So remember from section 4.6, when we have infinity over infinity, it's a do more work. And so the rule we learned in section 4.6 is divide top and bottom by the highest power in the denominator. And so I've done that here. I divided top and bottom by x, and then I took the limit. I get infinity plus 0 over 3, which is infinity. Whereas in the second problem, it's still infinity over infinity, but I divide top and bottom by x to the 5th, because that's the highest power in the denominator. And now when I take the limit, I get 0 over 1, which is 0. And those two examples together illustrate why we call infinity over infinity an indeterminate form. You have to do more work to determine what you're going to get. You might get infinity, you might get 0, you might get 7. Other indeterminate forms are these powers, 1 to the infinity, 0 to the infinity, 0 to the 0, infinity to the 0. Infinity minus infinity, you might think, well, that's 0, but it's not necessarily. It depends on how fast these two functions are going to infinity. But I just want to warn you that just because there's an infinity in the limit doesn't necessarily mean you have an indeterminate form. For example, infinity to the infinity, that's a big number to an even bigger number, that's infinity. Infinity minus 0 is infinity. And if you add two infinities, you still get infinity. So in these first few problems, we're just going to practice seeing for which limits we could apply L'Hôpital's rule, which states if you're taking the limit of a quotient of two functions f over g, and you either get 0 over 0 or infinity over infinity, and when I say infinity over infinity, I mean plus or minus, either one's fine, you can take the limit instead of the derivative of the numerator divided by the derivative of the denominator. And if that limit exists, that will be your limit. Don't use the quotient rule. It's much more simple than that. Just take f prime over g prime. Okay, so let's look at some examples. If you try and apply L'Hôpital's rule when you don't have one of these forms, then you won't get the right answer. And so it's important that you check every time that you actually have one of these forms before you apply L'Hôpital's rule. So for this first one, as x goes to infinity, we know, just keep in mind what the graph of ln x looks like. It goes up forever. So the numerator's infinity and the denominator's infinity. So yes, we could apply L'Hôpital's rule to that limit. We'll practice actually using it in a minute, but right now I just want to determine what's indeterminate. Next one, sine of 0 is 0, divided by, as x goes to 0, this is 0, so yes. Next one, limit as x goes to 0 from the right of cos x over x. Now, as x goes to 0 from the right or left, cosine of 0 is 1, so it's going to be 1 over 0 through positive values. No, could not apply L'Hôpital's rule to that. Next one, e to the negative x. Now remember, e to the x looks like this, and let me change the color of my pen. E to the negative x looks like this. So as x goes to infinity here, the numerator is going to 0, and the denominator is going to infinity. So no, we could not apply L'Hôpital's rule to that. In fact, if we wanted to find that limit, we would write that as the limit x goes to infinity of 1 over x e to the x. Make that exponent positive by putting the e to the x in the denominator. And then we get 1 over infinity would be 0. Okay, now the next one looks very similar, except now I'm going to negative infinity. So this green graph is going up, so I'm getting infinity. And in the denominator, I'm getting negative infinity. So yes, I could apply L'Hôpital's rule to that. All right, so now let's practice applying L'Hôpital's rule. Okay, this first guy, let's just check and make sure we can actually use L'Hôpital's rule. As x goes to 0, e to the 0 is 1. So on the top, I'm getting 1 minus 1, which is 0. And on the bottom, sine of 0 is 0. So this equals by L'Hoppe. I always put an LH over my equal sign when I use L'Hôpital's rule just to indicate to the reader that that's what I've done. Limit as x goes to 0. I take the derivative of the top, which is e to the x, and I take the derivative of the bottom, and I have to use the chain rule. I get 5 cos 5x. Now, let's see what we get. As x goes to 0, I'm getting 1 on top, and cos 0 is 1, so I get 5 on the bottom. So that's my limit. Next one, this is infinity over infinity. And so I can do this one of two ways. Method 1, no LaHop. Divide top and bottom by the highest power in the denominator. Okay, so that would be x squared. So 2x cubed over x squared is 2x. Negative 3x over x squared is negative 3 over x. And 1 over x squared is 1 over x squared. The denominator, I get 1 minus 5 over x minus 7 over x squared. Now I take the limit. I get 2 times infinity, which is infinity, minus 0 plus 0 over 1 minus 0 minus 0. So I get infinity over 1, which is infinity. Okay, let's try L'Hopital's rule. So 2, use LaHop. Since I have infinity over infinity, I can use L'Hopital's rule. So this is equal to, by using L'Hopital's rule, the limit as x goes to infinity. I take the derivative of the top, which is 6x squared minus 3, and I divide by the derivative of the bottom, 2x plus 5. Okay, now what do I get? I get infinity over infinity. What? Well, I can use L'Hopital's rule again. You can use L'Hopital's rule all day long if you want, as long as you keep getting infinity over infinity. Now, fortunately, we're going to not have to do this all day long. I think this should be our last go round. Let's check. We get 12x over 2. Now let x go to infinity. I get infinity over 2, which is infinity. So there are two different ways to do the same problem. One uses L'Hopital's rule, the other does not. Now, it's nice to know L'Hopital's rule because dividing top and bottom by the highest power in the denominator will not always work. So we need other methods like L'Hopital's rule. Okay, what if you don't have 0 over 0 or infinity over infinity? For problems that look like this, you can rewrite them, as 0 over 0 or infinity over infinity. Here's what I mean. Let's take a look at this problem. As x goes to pi over 2, cos x goes to 0, secant of 5 pi over 2. So here's pi over 2, 3 pi over 2, 5 pi over 2 is up here. Secant of 5 pi over 2 is going to be infinity. So let's just rewrite this. I'm not using any rules or anything, just rewriting secant. So it's to pi over 2 cos x over cos 5x. Okay, now as x goes to pi over 2, I get cosine of pi over 2, which is 0. Cosine of 5 pi over 2, remember where 5 pi over 2 is, it's up there, 0 over 0. So now I can use L'Hopital's rule. So this is by LaHop, limit as x goes to pi over 2. The derivative of cosine is negative sine x. And in the denominator, I have to use the chain rule. I get negative sine 5x, but then I have to multiply by a 5. Okay, now let's see what happens when I try and take the limit. As x goes to pi over 2, sine of pi over 2 is 1, so I get negative 1 upstairs. And sine of 5 pi over 2 is also 1, because 5 pi over 2 lives up here with pi over 2. So I get negative 5 in the denominator, 1/5. I think number 2 is a little bit more interesting. As x goes to 0 from the right, x is going to 0, and ln of 2x is going to negative infinity. So I'm getting 0 times infinity, pretty much. Well, 0 times negative infinity. Remember what the natural log curve looks like. Looks like this. I'm going to 0 from the right, so the y values are going down to negative infinity. that's why I have to approach 0 from the right. There is no approaching 0 from the left because natural log isn't even defined on the left. So here's what we're going to do. This is a cute trick. So I'm not using L'Hopital's rule yet. I'm going to rewrite this as the limit as x goes to 0 from the right. I'm going to leave the ln 2x upstairs. And then instead of multiplying by x, I'm going to divide by 1 over x. Okay? So just pause the video. Make sure you agree that these are the exact same function. Dividing by 1 over x is the same as multiplying by x. Okay, so what does that get me though? Now the numerator is going to negative infinity, and the denominator as x goes to 0, 1 over 0 through positive values is infinity. Now I can use L'Hopital's rule because I have plus or minus infinity over plus or minus infinity. So by L'Hop, limit as x goes to 0 from the right. Okay, the derivative of ln of 2x. Remember the rule, ln of u of x prime is u prime over u. So I'm going to get 2 over 2x, which is 1 over x. And in the denominator, this is the derivative of x to the negative 1, which is negative x to the negative 2. And to simplify the algebra, I'm going to write that as a fraction, negative 1 over x squared. Okay, now the important thing is when you use L'Hopital's rule and you get something crazy like this, simplify before you do anything else, because you might not have to do anything else. And in this case, we don't. So I'm not using L'Hopital's rule anymore. I'm just going to simplify this. This is the limit as x goes to 0 from the right of negative x. Okay, well that's 0. So our answer is 0. Okay, so let me just pause for a moment, go backwards. By far, the most common use of L'Hopital's rule will be something like this, where it's a straight up 0 over 0 or infinity over infinity.